Hello dosto, welcome to SQL JOINs. In this video, we are going to discuss on SQL joins. Joins in SQL are used to combine rows from two or more tables, and it is based on related column between them. We are using joins when we need to retrieve the data, and that data which is spread across multiple tables in relational database. So we can say if there is a student and whose address, okay, so student information and whose address information may have in two different tables, okay, and if we want the details of that particular students along with his address detail, in that case we can apply join on these two tables and we can retrieve the information about the students and get the desired result. Okay, so to get this desired result we are using these joins. There are different types of joins like inner join, outer join, cross join, and self join. Again, here this outer join is again segregated into three different joins like left outer join, right outer join, full outer join. Okay, there are two more new joins, semi join and anti join. And again we are calling them as a left semi join or and left anti join. So why we are calling them left, that we will check in the upcoming slide. Okay, so let's go one by one to understand all these joins in detail. Inner join. So inner join returns only the rows that have matching values in both the tables. So before inner join, let's understand when we are saying we want to apply join on two different tables. So definitely there should be some relationship in between those two tables. Okay. So for example, if we have two tables like product and category. Okay. So what could be the relation in between product and category? So we can say that one category could have many products. That is one to many relationship. Okay. Let me repeat again. One category can have multiple products, and that is one to many relationship in between this one. Okay, let's say there is a product table, product, and there is a category table. So product table we have columns like prod ID, and category have column category ID. Here prod name, here category name. Okay, now we want to apply this one to many relationship over these two tables, so we can use column category ID. So this is the foreign key of this category table. If we have categories like C1, C2, C3, and C4. Okay, there are four categories, and we have products with they have foreign key category ID like C10, C11, C1, and C4. Now, if you say C10 and C11, so if we apply this foreign key constraint, and if we are saying that C10 and C11, that database will not allow. If this foreign key value like C10 is not available in category, then it will not allow. Okay, but let's assume we have not used this foreign key constraint, but we have just created this table with all these columns. Okay, then definitely the database will allow it. because database don't know which constraints we are using, whether it is a foreign key constraint or any other constraint. Now, if we compare the category ID from this product table with the category IDs from this category table, we can say C10 and C11 is not a part of this category table. Okay, and whereas C1 and C4 would be part of category table. These are the common values C1 and C4. When we apply any join on tables, always remember two things. One would be your number of rows and number of columns. Okay, so if we apply this inner join, so here two values are matching, so we would get two rows. Now, how many columns? If we see here, we have three columns, and here we have two columns. So we will get total five columns in joins. Let me repeat again. Inner join returns only the rows that have matching value in both the tables. Let's move to next join. Now, left join. So again, I would say here we have three columns, here two columns. So left join. So when we say left join, it will return all the rows from this left table. If we say there are 100 rows in product table, and here we have 10 rows in category table. This is a left join, so we will get 100 rows from this product table. But here let's assume there are only 30 rows are matching with category. So category ID of 30 rows from product table is matching with category ID of category table. Okay, so still it is returning 100 rows, and since we are using left outer join, so we will get 5 columns in our output result, 3 and this 2. Number of rows equal to 100 and number of columns equal to 5. Okay, there are 70 rows for which we don't have matching category ID. Okay, and for those 70 rows we will get null values in columns of category table. So there are two columns. For these two columns we will get null values for all those 70 rows. Null category columns. The same thing is mentioned over here, like left outer join will return all the rows from left table and matching rows from the right table, that is 30. If no match found, then null value would be provided to the column from right table. What is the right table? Category. So for category, we will get null values. How many rows? For 70 rows. Okay, let's move to next slide. Right join. Now it is completely opposite to left outer join. Okay, so here as we discussed earlier, there are 100 rows in product table and 10 rows in category table. Since it's right outer join, so we will get all the rows from category tables. So out of these 10 rows, there are only 5 category IDs are matching with the category ID from product table. Okay, so for these 5 rows, we will get all the column values from category table as well as from product table. So again, number of columns equal to, so since here we have 3 columns and here we have 2 columns, so we will get 5 columns. For 5 rows we are getting category id matching in both tables. So for those 5 we will get some value for all the columns of product table as well as category table, but remaining 5 which are not matching, for those we will get null value for all the columns of product table. So same thing is mentioned over here. Right join returns all the rows from right table, that is your category table, which is having 10 rows, so it will return all 10 rows, and the matching rows from left table and the matching rows of left table. How many category IDs are there from category table which are matching with category ID of product table? 5. Okay, so this 5 would be there, and if no match found, if no match found, null values are returned for the columns from left table. So for the columns from left table, we will get null values for remaining 5 rows. Now let's move to next join, full join or full outer join. Here, as we discussed earlier, we have 3 columns in product table, 2 columns in category table. Okay, and here we have 100 rows, here we have 10 rows, and so we have C1, C2, C3, C4 and C5. These categories are matching with the category ID from product table as well as category ID from category table. Okay, now when we say full outer join, it is a combination of left outer join as well as right outer join. In case of left outer join, we'll get all the rows from left table, whereas in case of right outer join, we will get all the rows from right table. Okay, so we can say here we have 100 rows from product table and category having 10 rows, but let's assume there are 5 rows which are matching, only 5 rows. Okay, now we have some category id like C9 and C10, which is not available in product table. If we say full join or full outer join, then we will get all these 100 records from product tables, plus since there are 2 records which are not matching, only 2 records which are not matching with category id of product table, so this 100 plus this 2, so we will get around 102 rows in our output. This is number of rows. What about number of columns? Again 3 plus 2, 5. For this C11 and C12, we don't have any entry in category table, so for those rows we will get null value to all the category related columns. Similarly for C9 and C10, we don't have any value in product table, so for C9 and C10 we will get null values to all the columns of product table. Okay, so same thing is mentioned over here. If we say full outer join, then it return all the rows when there is match in either the left table or right table. If there is no match, null values are returned for the column from the table not having any match. Okay, now let's move to next join, cross join. Now this is an interesting join, because when we apply this join on two tables, like here we have applied on product as well as on category, there is no any condition we have added, because since it's a cross join, it's a cartesian product. We have product table and we have category table. Okay. For product table, we have P1, P2. For category, we have C1, C2, C3. Now, when we say our output, in output, we will get, since here we have one column, here we have one column, so definitely we will get two columns in output. Product ID and category ID. Here we have P1. For P1, since we are saying Cartesian product, so it will do the combination with all the rows from category. So P1 with C1, P1 with C2, P1 with C3. So here we will get C1, P1 with C2, P1 with C3. Okay. Again, similarly, P2 will also do the same a similar combination with C1, C2, and C3. So we will get P2, 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 C1, C2, C3. So here we can say that how many rows are created? 6 rows. That is 2 into 3. But again, always remember, if there is a null value, then this calculation may be less than this multiplication. Okay. Or even if there is a duplicate entries, then also this multiplication value would not be correct. It would be less than this multiplication. Now let's move to next join, that is self join. Now since it's a self join, so definitely join is applied on the same table itself. Okay, and same is mentioned over here as well. When a table is joined with itself, then we are calling it as a self join. But interesting thing is that we are not using any clause like self join over here. We have to use either inner join or left outer joins clause. Since it's on same table, we can say employee as well as employee. So same table is there and we are applying inner join or left outer join. So will it work? It will not work. So to work it, we have to apply alias, and that alias should be different. So here for first table employee, we are giving alias E. For second table employee, we are giving alias M. And for on condition, we are applying the condition like E dot manager ID should be equal to M dot manager ID. Okay. So since we have used this one on employee table, so you might understand that we can apply this type of self join on the table which is having hierarchical data. If we say we have employee table, employee, we would have ID, then name, and then whose manager ID. Okay. If we execute this query, we will get output like all the details of this employee along with whose manager's detail like manager's ID, manager's name. Okay. So if there is a requirement where we want the employee information as well as whose manager's information in single row, in that situation we can use this self join to get the desired output. Now semi join or left semi join. So before going to this semi join, let's brush up on some inner join. Okay, as we discussed earlier, in case of inner join, we will get all the rows having category ID value matching in both the tables. Okay, Let me repeat it again. In case of inner join, we have rows which are matching the category ID value in both the tables. Okay, if there are 50 records, okay, then we will get output as the 50 rows. Now, since we are saying this is a left semi join, so we can say we will get 50 rows, but all the columns only from left table. Okay, so we will get 50 rows, but how many columns? If we have 3 columns in product table and 2 columns in category table, okay, so in case of inner join we will get 50 rows and 3 plus 2 5 columns, but in case of left semi join we will get 50 rows but only the columns from left table, that is 3 columns. So here we can say number of rows equal to 50 and number of columns equal to 3, and the same thing is mentioned over here. Semi join returns rows from the left table that have matching value in both the tables. Since we need only columns from left table, so we have used select star from product, so it will provide only columns from product table. And in where clause we are using exist, and in this exist we have applied this condition where category id from category table, and again that category id should match with the product id, products category id. Similarly, we can define this semi join using in operator. So here we are using select star from product where category id in, and here for this in we are providing the list of category ids from category tables. Now let's move to anti join. Anti join or left anti join. So you can see that we have highlighted product table, so definitely we will get all the columns from product table, but which all columns which are not matching with category. Okay, that's the reason this particular part is not highlighted. So we will get all the rows from left table that are not having any matching value with right table. And same is mentioned over here. Anti-join returns rows from left table that not have matching value in both the tables. If we apply star over here and if we remove this where clause, then we can treat this particular query as a left outer join. So we can say query is the same one, only some minor changes we have applied over here. First change is we have added where clause with is null check, and rather than applying star we can consider the columns only from product table. Okay, so let's do some practical to understand joins in more detail by using practical examples.